Okay, so back in section 6.1, we looked at systems of equations and we solved them by graphing. What was good and bad about graphing again?
It didn't give you like fractions.
Yeah, if your answers came out to be fractions or decimals, the graphing method was not going to work. It was going to be really, really bad. What else?
It was good because it was visual.
It's very good because it's very visual. It's very good for visual people. Very easy to learn that way. What else? Kind of a pain, I think, because you had to make sure you drew everything very accurately. You had to have nice straight axes and even tick marks, and you had to have a nice straight line and another nice straight line for it to work. If you didn't draw it well, you weren't going to get the right answer.
That's pretty good with a graphing calculator.
If you know how to do it on a graphing calculator, it works very well on a graphing calculator. That's true. And truthfully, back when I took algebra, graphing calculators didn't exist. It's a long time ago, by the way. The graphing method wasn't really heavily emphasized. We really learned to do substitution and what we're going to learn today, elimination. But with the advent of graphing calculators, graphing has become much more popular. Anyway, how about substitution? What was good and bad about substitution?
It worked even if you had fractions and decimals.
It will give you the answers, even if you have ugly fractions or ugly decimals. Yep. What else?
It's faster than the graphing method?
I think it's faster than the graphing method. I would agree. Anything else? Anything bad about it? All right, let me give you an example of bad. How about 2x plus 3y equals 7 and negative 2x plus 5y equals 1. So how did that substitution work? Substitution said, pick one of the two equations, it doesn't matter which one, and get one of the letters all by itself. So which equation do you like and which letter do you want to get all by itself? There really isn't a good one, is there? Why not?
There won't be fractions?
Because no matter what I do, I'm eventually going to have fractions. For example, let's just do it. Let's take this first equation and get the y all by itself. What would you have to do to get the y all by itself? Subtract 2x. So you would have 3y is minus 2x plus 7. And then divide by 3. And divide by 3 everywhere. Y is minus 2/3 x plus 7/3. And then, I'm not going to work it all out because I don't think you're going to want to do it. You would have to take this, plug it in there. You're going to have a whole bunch of fractions and you're going to have to solve. Is that going to be good? No. And that's why we have a different method called the elimination method. And this is where we use the elimination method. The substitution method is very, very good if you have one of the variables that only has a coefficient of 1. So if this 3 wasn't here, this wouldn't be so bad because I wouldn't have to divide by that 3 and I wouldn't get the fractions. That's when substitution is really, really good. Substitution is really, really good when one of the letters has a coefficient of 1. But that doesn't always happen, and here's a good example. Okay, so here's how we're going to do elimination. Step 1. Pick a letter. You pick X or you pick Y. You pick one or the other. Does it matter which one? No, but we'll see that sometimes one is easier than the other. So we pick a letter. 2. Multiply the equations by appropriate numbers so that the coefficients of your letter are opposites. That sounds very confusing. It'll make a lot more sense when we do an example. Sounds confusing. Not too bad, actually.
So basically, substitution is good when the coefficient's 1.
Substitution is very good when one of the letters has a coefficient of 1. If none of the letters has a 1, then you're usually going to be stuck with fractions, and then substitution will work, but it's a pain in the neck. And we'll see that this elimination method avoids our fractions for us. Okay? So step 2 sounds confusing. We'll see in a few minutes it's not so bad. Step 3, add the equations. Eliminating your variable. Eliminating your letter. And finally, step 4 is simply solve. Okay, so let's take a look at this system again. 2x plus 3y equals 7. Minus 2x plus 5y equals 1.
So the x is already, the coefficient's already the same, so we just combine and solve?
All right, so this one's very easy. Step 1, we pick a letter. And you're telling me I should pick x.
Yeah,
And the reason you're saying x is you're looking at the coefficients. This one has a 2, and that one has a
negative 2.
-2, and that's what we want. We want the coefficients to be opposites. So if this one's a 2, we want that one to be a -2. That's exactly what we want. That's what step 2 says. Step 2 says make it so the coefficients are opposites. And they already are. Step 3 says just go ahead and add the equations.
8y equals 8.
Yeah, because what's 2x minus 2x? 0, right? The x is added up to 0, and that's why it's called elimination. We just eliminated the x. We made it go away. 3y plus 5y is 8y, and 7 plus 1 is 8. Now can you solve? Yeah, divide by 8. Y is?
1.
Y is 1. We're almost done. What's left to do?
Plug
Plug
it
it
in.
in.
Plug it in. Which one do I plug it into?
Either one, right?
Whichever one you like. Which one do you like?
Top.
I like the top one because it doesn't have any minus signs. Less chance for me to make a mistake. 2x plus 3 equals 7, because I plugged in 1. 3 times 1 was 3. So 2x is 4, x is 2. So my answer would be 2 comma 1. And notice, at any point anywhere, did I have to deal with fractions? No. And that's the big advantage of the elimination method. The big advantage of the elimination method is if these coefficients aren't 1, we can still solve but not have to deal with fractions.
Fractions are fun, though.
I agree, I like fractions, but I do find that I make more mistakes when I have fractions, just because there's more to deal with. So if I can avoid the fractions, I will. If I have to deal with the fractions, I'm probably going to use my calculator to deal with those fractions. That helps me a lot.
So
Like,
you plug in that 1 just for the x.
I plugged in the 1 for the y, because y, it was a y number.
Okay.
So I plugged it in right there. 3 times 1 gave me 3.
Okay.
All right, now, of course, they're not all that easy. Let's find another one. How about x minus 4y equals 5, and 5x minus 2y equals negative 11. Well, based on what I just said a few minutes ago, this would be a good one to do by substitution. Why would it be a good one to do by substitution? This x has a coefficient of 1. I could just add 4y to both sides and I could do substitution. It would work just fine. But let's do it by elimination anyway. So to do it by elimination, we pick a letter. Do you like x? Do you like y?
X.
You like x, okay? What you need to do is you need to look at your coefficients. This one's currently at 1 and this one's a 5. You need to multiply the equations by things to make it so they have the same coefficient, but one of them's positive and one of them's negative. So what might you multiply by?
Negative 5.
Take the top one and multiply by negative 5. Why multiply by negative 5?
Because 1 half negative 5 is negative 5.
That'll give me a negative 5x there and a positive 5x there. And that's what you want. You want the numbers to be the same, except one positive and one negative. So I'm going to take this top equation, and I'm going to multiply everything by negative 5. That gives me negative 5x plus 20y equals negative 25. And make sure you multiply everything by negative 5. A real big mistake, people will forget to multiply this number over here. And they'll write a 5 right there instead of a negative 25. Make sure you multiply everything. Second equation I'm not touching. I'm just going to write it down again. 5x minus 2y equals negative 11. And notice what we've done. What have we done?
Cancel the 5.
We set it up so that the x's will cancel out. The x's will add to 0. And that's what you want. Would it do any good to just add these two equations right from the beginning? No, because nothing would go away, would it? Nothing would add up to 0. So you've first got to set it up so that things will add up to 0. I add. The x's add to 0. 20y minus 2y. 18y. Negative 25 minus 11.
Negative 36.
Negative 36. Divide by 18. Y is?
Negative 2.
Negative 2. Last step.
Plug it in for one.
Plug it in for y. Plug it into which equation?
Either one.
Either one. Which one do you like better?
The top one.
I like the top one better because the x is almost already all by itself. Bottom one would work just great, but I'm going to use the top one. I think it's a little bit easier. All right, so I'm going to have x. And then what happens when I plug in negative 2? Negative 4 times negative 2 is? Positive 8 equals 5. Subtract. X is negative 3. Answer! Negative 3, negative 2. Questions on that one? How about 2x minus 3y equals 8. And 5x plus 6y equals negative 7. X minus 3y equals 8. 5x plus 6y equals 9. The most common mistake I make when I do these is I copy them down wrong. Sometimes I'll read like one equation from problem 5 and one equation from problem 7, and then it doesn't work out very nicely usually. But, okay, that's my problem. We pick a letter. Which letter do you like?
Why?
Why do you like Y?
Because it's 3, 6, 9. It's easier to. You can't come. It's going to be harder to multiply. You can't multiply something that will equal 2 to 5.
Sure you can.
One's even one's odd, so it'll be harder.
Okay,
Right?
I agree with you that Y is easier. What do you have to do so that you'll make the Y's add up to 0?
You just multiply number negative
By
by
negative
2.
by 2, yeah.
Multiply the top one by positive 2 even, right? Because that'll give you a negative 6y and a positive 6y. You can do the x's, it's just harder. To do the x's, what you would have to do is multiply this one by 5 to get a 10 right there.
Oh, and multiply the other one by 2.
Multiply the other one by negative 2 to get a negative
Or you could
10.
go negative 5 and then 2 also.
You could go negative 5 with this one and positive 2 with that one. The point is, you can do the x's, but you have to multiply both equations. And sometimes you're going to be forced to do that. The next example, we're going to be forced. But this one, looking at these, I would say y is slightly easier because to do the y's, I only have to multiply one equation. And that's something that I tend to look for. I tend to like to make things as easy as I can on myself. And so that's what I would do. I would take this equation and multiply everything by 2, and that will make my y's add up to 0. 4x minus 6y equals 16. 5x plus 6y is negative 9. I add. This time my x's survive, 9x, but my y's are eliminated. And 9x equals 9. So x is
1.
left is 1. Then what do?
Plug it back.
Plug it in. And just to be different, this time I'm going to use the bottom equation. I've used the top equation every other time. Again, I don't really think it makes a difference. I don't think one's significantly easier than the other. That would give me 5 plus 6y is negative 7. 6y is negative 12. Y is negative 2. So my final answer is 1 comma negative 2. Questions on that? Okay, how about one where we don't have a choice here? Minus 8x plus 3y is 1. And 3x minus 4y equals 14. Minus 8x plus 3y is 1. 3x minus 4y equals 14. This time, I don't think it makes a big difference which letter you pick. I don't think one's really that much easier than the other. So which letter do you like?
I like the Y numbers,
You like the y numbers. Personally, I would probably go with the y numbers
just because their products will be smaller than.
because they're a little bit smaller. 3 and 4, I'd rather avoid that 8, I guess, if I can. Okay, so what are we going to do for the y's? We're going to take this top equation and multiply it by
Put it top by 4.
4, and that'll give us a positive 12. And the bottom one we're going to multiply by
Sorry.
positive 3. Good, you caught yourself. It already had a minus sign in it, didn't it? So that'll give us a positive 12 on top and a negative 12 on bottom. Those will add up to 0. Okay, so that happens. Sometimes you have to multiply both equations. No way around it. Is that hard? Slightly harder, but still better than fractions? Still better than fractions. All right. Negative 8 times 4 is negative 32x. Plus 12y is 4. And that's going to be 9x. Minus 12y is 42. I add those together. Negative 32 plus 9. Negative 23. X. The y's add up to 0. Equals 46. Divide. X is negative 2. Which equation do you want me to plug that into? Top one? Okay. When I plug negative 2 in, I have negative 8 times negative 2, that's 16. Plus 3y is 1. 3y is negative 15. Y is negative 5. Questions on that? All right, last problem for me. How about 2/3 x plus 1/2 y equals 1/6, and 1/2 x plus 5/4 y equals 11/4. Nobody ever said we were never going to have fractions. What do you do?
They have to be exact opposites from each other.
Yep.
So you take the x numbers then, would you?
I don't know.
You have to make them all the same denominator.
I don't have to.
You can cancel
Something with the denominator, though.
You can cancel off the fractions.
First thing I would do is make the fractions go away. So what do I do to the first equation to make all the fractions go away?
Multiply by 6.
I'm going to take the first equation and I'm going to multiply everything by 6. So the first thing I'm going to do is I'm going to get rid of the fractions because I think those are difficult to deal with. 6 times 2/3 is 4, so that's 4x. 6 times 1/2, 3y equals 1. Looking better already. What am I going to do with the second equation? Multiply everything by 4. Four times a half, 2x. 4 times 5/4, 5y, equals 11. So if I had a problem, and my problem had fractions in it, first thing I would do is get rid of all the fractions. If I had a problem and my problem had decimals in it, first thing I would do is, no, I would just go ahead and multiply and get rid of the decimals right from the beginning. So if I had like a 0.3x, how do you get rid of a 0.3? You multiply it by?
Negative.
No.
A 0?
Well, if I multiply by 0, it'll certainly make it go away, but I'm not allowed to do that. Multiply it by 10. What does multiplying by 10 do? It moves a decimal one spot. So if I had a 0.3x, I'd multiply by 10. What if I had a 0.03x? Multiply by 100, so on and so forth. So if I had a problem with a whole bunch of decimals in it, I'd multiply by 10 or 100 or 1,000 or whatever I need and make all the decimals go away. Same idea. All right, now we're in good shape. Which letter do you want to cancel out? X. What do you have to do to make the x's go away? Times by -2 to make this a -4. All right, so top one I'm leaving all by itself, not doing anything to it. 4x plus 3y equals 1. Multiplying by -2 gives me -4x minus 6y equals -22. Add those up. Minus 3y is -21, so y is 7. What am I going to do with that y equals 7? Plug it back in where?
Plug it in for the y. Whichever one you want.
Which one do I want?
4x plus 3y equals 1.
Yeah, very good. Don't go back to the ones with fractions in them. Don't mess with those things. Take this 7 and plug it into one of these two equations. These equations are exactly the same, just one has fractions and one doesn't. Use the easy one. Use the one without the fractions.
If you were multiplying by -2, wouldn't -2 times 5 be -10?
Yeah, it should be -10.
Yeah, I got y equals -3.
Yeah, y should be -3.
So what you're telling me is 2 times 5 is now 6?
No.
Oh, man, and I wrote it in pen. All right, so you're absolutely right. 5 times 2 is 10. You know, that's kind of lucky. Usually when you make a mistake, you don't get a real nice answer. Usually when you make a mistake like that, you get an ugly fraction, and that's how you know you made a mistake. So I got lucky there. I did it wrong, but still got lucky. All right, so then 3 plus -10 is -7. And I divide, and I agree with you. I should have had y equals 3. All right, so see, everybody makes mistakes. It happens. It's not intentional. Now, moral of the story is, take this 3 and plug it into one of the easy equations. I'll go ahead and use this top one. That's going to give me 4x plus 9 is 1. 4x is -8. X is -2. So my answer turns out to be the point, -2, 3. All right, last thing we need to talk about. Sometimes you get inconsistent and sometimes you get dependent. What's that going to look like here? Well, let me give you an example of one. How about (2x minus 4y equals 1) and -3x plus 6y equals 8. What would you do?
Multiply multiply the top by 3, I guess. Or by, oh, you,
Multiply the top by 3, that'll give you a 6x,
and the bottom by 2.
and that'll give you a
Negative.
negative 6x. All right, that sounds perfect. Multiply by 3, multiply by 2.
Would be negative 3 or regular?
Regular 3, because 3 times 2 is going to give me 6, and this one already had the negative, so negative 3 times 2 will give me a negative 6. 6x minus 12y equals 3. Negative 6x plus 12y equals 16. Not only did we cancel out the x's, we also... So what do we have on the left-hand side? 0 equals
19?
Yeah.
19. When does 0 equal 19? Never. So what does that mean? Inconsistent. What will it look like if the answer is dependent?
It would be the same.
You get the same on both sides. And if it's dependent, you're going to get 0 on this side, which means you will get
0 on the other.
0 on that side. When does 0 equal 0?
Always.
Always, and that's dependent. So that's what inconsistent and dependent are going to look like. Almost exactly like they did for substitution. For substitution, when we saw something like 0 equals 19, we knew that was wrong, so we wrote inconsistent. If we get 0 equals 0, we'll write dependent, and that's all. Questions?
This is off topic, but it's about the final. Are we